Hello guys, in this video we will be learning about linear inequalities with two variables, graphing linear inequalities with two variables. In the previous years you learned how to graph linear equations and you also learned how to solve linear inequalities. So now we are going to study graphing linear inequalities. So let me walk you through some steps of graphing linear inequalities. When we solve a linear inequality for two variables, it turns out that there are lots of solutions and we can visualize them by graphing. So, if we were to replace inequality symbol with equality sign, then we would actually be describing some kind of line. So in this context, that's called boundary line for the solution. So the first step we need to do to graph linear inequality is finding the boundary line. So let's take a look at the first given figure. In this given figure, the equation is given as y equals 2x minus 4. So you have to find the boundary line first. You can remember how to do so from previous years. You were finding x-intercept, plotting the point on the x-axis. You were finding y-intercept and plotting the point on the y-axis and connecting them by using a line. This is how you find the boundary line. What if your equation is not an equation, it's an inequality? You have less than or greater than, less than or equal to, or greater than or equal to symbol. So what happens when you have these kind of signs? So if we have less than or equal to or greater than or equal to, then you are going to include this boundary line into the solution. So we are going to use solid line because line is included. However, when we have less than or greater than, we are not going to include the boundary line to the solution. So we are going to use dashed line. So we start finding the boundary line. So let's suppose we found the boundary line here. And our equation is y is less than or equal to 2x minus 4. You found x-intercept, you found y-intercept, you found boundary line, and the next step will be finding the correct region to shade because we have infinitely many solutions. So one part of the line will be our solution. Either below line or above line will be our solution. So when we have less than or equal to symbol, we have to shade below line. This region will be our solution. On the other hand, if we have greater than or equal to symbol, we have to shade above boundary line. So whether you have greater than or equal to. When you have greater than or equal to, your line will be solid. Less than or equal to, line will be solid. But if there is no equality, there is just less than or greater than, then you have to use dashed line and shade the corresponding region. If it is less than, shade below line. If it is greater than, shade above the line. So let's take a look at the question. I'm going to explain you two different ways of graphing linear inequalities here. I will solve two examples with two different ways. So first example, first way. In the first example, we have y is less than 1 over 2x plus 1. So the first way, is writing the inequality in slope-intercept form. Slope-intercept form. You remember what slope-intercept form is? It is when our y is on one side of equation or inequality, everything else is on the other side. So in this given inequality, it's already given as slope-intercept form. Y is on one side, everything else is on the other side. So if we have such equations, inequalities, we can shade below of the line if there is less than, above of the line when there is greater than. So in this example it's less than, so we are going to shade below the line. So first of all we find the line then. So how do you find the line? By finding x and y intercepts first. If we know what x and y intercepts are, by connecting them we can find the boundary line. So x-intercept, your y is 0, y-intercept, your x is 0, right? We studied this in the first section as well. So when y is 0, 0 is equal to 1 over 2x plus 1. You pretend that you see here equality. To find the boundary line, you suppose that there is equation here, y equals 1 over 2x plus 1, and find intercepts accordingly. For x-intercept, you let y to be 0. 0 equals 1 over 2x plus 1. Bring 1 to the other side. Negative 1 equals 1 over 2x. When you do cross product, x is equal to negative 2. X is equal to negative 2. So negative 2 is the x-intercept, 0, negative 2, 0. What about y-intercept? This time your x is 0. Y is equal to 1 over 2 times 0 plus 1. So you have y equals 1. Y equals 1 will be your y-intercept. So you connect these 2 points by using solid or dotted line. Since our inequality is less than, we're going to use the dotted line, dashed line, to connect these 2 points. So let's use dashed line to connect these 2 points. Like this. And the final step would be to figure out what side we have to shade, what region we have to shade. So when you look at the symbol, it's less than symbol, so we shade below below the line. So you shade this part. So this part will be your solution. Every point in this region will be your solution. It doesn't matter what point you pick in this region. Every point should satisfy this inequality. So the whole region here, the region below the line, will be your solution. So this was the first way. Let me continue with the second way. Second question. So in this question, the equation inequality is not given in slope-intercept form. So you either use the first way, write your inequality in slope-intercept form, or second way, we use a test point to decide what region to shade. So I find using second way easier here if the inequality is given in general form, because isolating y will take time. So it's not necessary. We have an easier way here. So I'm going to explain how to use test point to find the correct region to shade. So first, let's find intercepts. What is your x-intercept? Your x-intercept is when your y is 0. So when your y is 0, 2x is equal to 6. You pretend that this inequality is an equation so that you can find your intercepts. 2x plus 3y is 6, so 2x is 6, then x is equal to 3. X equals 3, let's find 3 on the graph, plot the point. This is your x-intercept, your y-intercept. This time you let x to be 0, so 0 plus 3y equals 6. Isolate y, divide both sides by 3. Y will be 2. Where is 2? 2 is here on the y-axis. So you got your intercepts. So the next step will be finding the boundary line. So by connecting these 2 points, you'll find your boundary line. So what is the symbol here? The given symbol here is greater than or equal to. So we are supposed to use a solid line here. There is an equality. So connect them by using a solid line. My drawing is not good. Let me try again. One more time. So this is our line, and the final step would be figuring out the correct region to shade. Since that's greater than, we can't say we have to shade the upper part because y is not alone. So you either get y by itself, use the first way, as I said it takes time, or use a test point. So what do I mean by test point? You pick a point on the graph, any point that you want. It doesn't matter what point to pick, but it's better if you use some easy points. What is the easiest point? What do you think is the easiest point? I think the easiest point to pick is 0, 0 origin because it's easier to substitute. So let's use 0, 0 as a test point. Test point 0, 0. So it means you use 0 for x, 0 for y. Plug in 0 for x, plug in 0 for y in the original inequality and see if it is in our solution. So let's see. You substitute 0 for x, 2 times 0 plus 0 for y, 3 times 0 is greater than or equal to 6. 0 on the left, 6 on the right. 0 is greater than or equal to 0, which is false, which means 0, 0 is not a part of a solution. If 0, 0 is not the solution, then we are not shading this region. We are not shading the region including 0, 0. We have to shade the other part, the part that we don't have 0, 0. So you shade below, above line. So this is your solution. No matter what point you pick in this solution set, it will satisfy this given inequality. But from the other part, you pick any point that you want, it will never satisfy. It will always result in wrong. So this is your solution, and this is the second way. So graphing inequalities with two variables is not a big deal. The first, produce the boundary line, dot it or keep it solid depending upon the inequality type, then figure out which region you should shade.